Hello. In this video, I'm going to be explaining how you can solve round robin. So how you can schedule processes using the round robin. As we have agreed before, round robin is a preemptive algorithm. This preemptive algorithm depends on time, so it's time-based. As I've told you in lectures before, the preemption can happen because of event-based interrupts or time-based. An example of event-based is something like shortest remaining time first, something like priority-based, earliest deadline first. Those are all event-based. The time-based, the example of the time-based is round robin. Also, the multi-level feedback queue is time-based. Okay, let's schedule those processes from time 0 to 3. It's idle, because your very first arrival is at time 3. P1 arrives at time 3. The burst of P1 is 7, and the quantum is 3. This means that P1 will take the whole quantum. So it's going to work from 3 all the way to 6. Okay? And the remaining time here of P1 is going to be a 4. Why 4? The burst is 7, and you consume 3 time units. In round robin, to solve it correct, or to make sure that your solution is correct, you need to take the queue, the ready queue, into consideration. Okay, so let's take this ready queue here. As you can see, at time 0, T is time, okay? As time 0, the queue is actually empty, okay? And then at time 3, I have P1, that's time 3, that is on top of the queue, okay? If you look at the table here, P2 arrives at time 5. So at T equals 5. Okay, here you have P1 in front of the queue, and you have P2 after. That's T equals 5. But then at time 6, the quantum expires. The time assigned for P1 expires, right? So at time 6, what's going to happen here is as follows. P1 will leave the running state and go back to the ready state, so ready queue, right here. And P2 is going to be in the running state. Okay, the one in head of the queue is the one in the running state. So this is at time equals 6. All right, and then P2 has a burst of 2. So P2 will work from 6 all the way to 8. Why not 9? The quantum is 9, is 3. Well, yeah, but the burst of P2 is 2. So it's not going to take the whole quantum. What if it does? It means that you're leaving the CPU idle, which is not really allowed in any operating system scheduling mechanism. So this means that P2 has a remaining time of 0. Okay? Now, while P2 is working and before it's done, we have an arrival here. What is the arrival? The arrival is the arrival of, as you can see, P3 that arrives at time 7. Okay, so at time 7, the queue will look like this. As you can see, P2 is working, P1 is waiting in the queue, and then we have P3 that arrives at time 7. And then at time 8, two things happen. Okay, at time 8, two things happen. Look at that. The first one is the fact that P2 will finish execution, and the second one is the arrival of P4. So now the queue here at time 8, P2 will leave, so P1 is going to be on the head of the queue, and then you have here P3. Sorry about that. Oops. You have here P3, and then you have P4 that arrives at time 8 also in the queue. That's P4. P1 has a remaining time of 4, and the quantum is 3. So P1 will work from 8 all the way to 11, and now the remaining time is 1. Okay? At time 11, P1 finishes, and you have an arrival. So here, this is time 11. P1 will finish the quantum, so it will leave the processor and go back to the queue. So you're gonna be having here the queue P3 on top, P4, P1, and then you have here the arrival at time 11, P5. Someone can ask me, why P1 and then P5, not P5 and then P1? Because they both happened in the exact same moment. You're right. In this particular case, if you look at that, P1 finishes execution and you have a P5 as an arrival. So which one will come before the other one in the queue, that doesn't matter. Okay? Now, the burst of P3, let's look at it. P3 has a burst of 4. That's the one on top of the queue. So P3 will work from 11 all the way to 14, and the remaining time here is 1. Okay? All right, so this means at time 14, let me see if there's anything. Oh, sorry. There is an event that happened here at time 12 before the 14. Do you see the P6? So at time 12, now the queue has P3, P4, P1, P5, then P6. That's time 12. At time 14, as you can see, P3 is done with the quantum. So P3 will leave the head of the queue and go in the end of the queue. So now the queue has P4, P1, P5, P6, and P3. Okay? Now, the quantum of P4 is 9, as you can see. So P4 will take a full quantum, the burst. So it's going to be from 14 all the way to 17, and the waiting time here is 9 minus 3, that would be a 6. Okay, that's P4. And then P4 is done, and it will go back to the end of the queue. Here it is. So now you're going to be having P1, then P5, then P6, then P3, then P4. If you look at P1, the remaining time of P1 is 1, as you can see, right? So P1 will work from 17 all the way to 18, and the remaining time is 0, which means the new queue will look like this. Here, P1 leaves, and now you have P5, then P6, then P7, then that's not a 7, that's a 3, right? Sorry. Here, P3, and then a P4. So P5 didn't work before. The burst of P5, as you can see, is 1. So now P5 is going to work from 18 to 19. The remaining time is 0 because it's done. All right, I forgot to write the times here. I'm so sorry. So this is going to be P4. That would be at time 14. This is time 17. P5 at time 18. Now, let's... Hello?
Can I ask
Yeah?
one month?
Yeah, sure. Oh, yeah. Take one. That's fine.
Thank you so much.
Yeah. Then here, P5 starts at time 18. It's going to finish at time 19. No problem. Okay. So when P5 finishes and leaves, now the queue is going to be P6, and then P3, and then P4. Here is the time equals 19. Okay. Now P6 has the turn. What is the burst of P6? P6 is 2. So P6 is going to work from 19 to 21 with the remaining of a 0, right? So now at time 21, this will leave, and you will have in the queue here P3 and P4. This is time 21, all right? What is the remaining time of P3? The remaining time of P3, as you can see, is also 1. Okay, so this means from 21 to 22, P3 finishes, right? So at time 22, P3 leaves, and the queue now has P4. The remaining time of P4, as you can see here, is 6, right? So P4 will take the first quantum from 22 to 25. The remaining is 3. And P4 will take from 25 to 28. The remaining here is a 0. Okay? So here it is. This is gonna be like that. P4 at time 25, and then this will leave at time 28. Now at time 28, the queue is empty. Okay. Let's get the sum of the burst. The sum of the burst. This is going to be a 7 plus 2 plus 4 plus 9 plus 1 plus 2. This is going to be 10, 19, and then 25. And you started at 3, so it will finish at 28. Correct. Now you can calculate the average remaining time and the turnaround time, the response time, the same way we did it in the shortest remaining time first, of course, right? The only equation that is valid here is the for the waiting time is finish minus arrival minus the burst, okay? You know what?